concerned? Well, first of all, we know about the law of Bergoni and Tribune-Doe. So that's one of the reasons we don't like to expose pregnant women to radiation, because that's probably when the fetus is the most sensitive. You know, later on we'll discuss some of the things that we see, but typically what happens is this. We have what we call direct effects, and we have indirect effects from radiation. Direct effect is when the radiation hits the DNA. And so the radiation that comes in, it typically will damage an area here, and then if that area is able to repair itself, which happens most of the time, that's good. If it doesn't, then this is what we call a point mutation. In other words, the information is not present, so depending upon what that part of the cell does, this may regulate its growth and cause cancer, or it may just die. You know, anything can happen. It just depends where that break occurs and if it gets repaired or not. This is approximately 5% of the damage that we see from radiation. And then, like I said, most of it gets repaired. Remember I told you that when your body has the ability to synthesize the DNA and repair it, we also have, well, we'll talk about the indirect method here. With this method here, the radiation typically will ionize water or some other covalent bond in your system. You know, we already said that water is 80% of your body. And sometimes you'll hear this thing called the poison water theory. But basically what happens is this: the radiation comes in, and if you remember that a water molecule actually kind of looks like Mickey Mouse. We have 2 hydrogens and 1 oxygen. So if I remove an electron from a water molecule, it destabilizes it. And it will break apart, and it will form a hydrogen ion and a hydroxyl radical. Now, what do you remember about radicals? Okay, well, I'll tell you, since if you don't remember, they're very reactive chemically. So if these things form around your DNA, it's going to tear it to pieces. But that isn't the problem we normally see with this. In fact, let me show you the other effect. This electron that was knocked off, it will sometimes go over to another molecule of water, and it will get picked up by that, which causes a destabilization of this water molecule. And then what I wind up with this is a hydrogen radical
What's destabilized the second water molecule?
This electron that was knocked off, it will travel over here and get picked up by this other water molecule. Because remember, water is a very weird substance. It has 2 covalent bonds. Remember, hydrogen only can form a covalent bond. It would love to have 2 electrons in that S shell, but it can't. There's no way that it can do that. So the only thing it can do, I'm sorry, the K shell. In the K shell, all it can have is 2 electrons. So it shares an electron with oxygen. Now this is why water is such a good solvent. You know, most people think that, you know, they watch those soap commercials, and if they buy Tide or some other laundry soap, that it's the soap that does the cleaning. You know, so you girls that buy the laundry soap, or Greg, you buy the laundry soap, what does the soap actually do?
the water that does the cleaning.
It's the water, yeah, all the soap
It's
that,
the mice.
Smell. It smells good.
it smells good. Yeah, it makes it not stink so much, but it's called a surfactant. Okay, you know, surfactant breaks down the water tension. So that's all soap does. It has, you know, so I mean, but anyway, it's the water that actually does the cleaning. But in this case here, when you have these radicals, so we have a hydroxyl ion here. These radicals, they can recombine. And this is where the problem is. If I get two hydroxyl radicals combined, then I get H2O2, or hydrogen peroxide. Most people that die, now this is 95% of the damage, by the way. Okay? So the water being ionized in your body is actually a negative thing. You also get peroxide. I mean, sometimes these things recombine and form water, sometimes they combine and form hydrogen gas. You know, it just depends. But these are the two bad ones here. So most people that die from radiation poisoning actually have the same characteristics as somebody who dies from this type of poisoning. Remember we had talked a couple of weeks ago about the NK killer cells? The cells that go around in your body to kill other cells, this is what they inject into them to destroy them, peroxide. We use peroxide to, you know, clean wounds on our skin, right? Okay? Or whiten your teeth if you go to the dentist. Okay. But your body,
What two radicals combine to form the
HO2? Hydrogen radical and an oxygen atom. Your body, I remember I told you guys a long time ago, you have an enzyme in your body. Now over time, now I don't know if this is an evolutionary process, I'm sure it must be, because if you were a caveman living on the planet, you know, hundreds of millions of years ago, or however long we've been on Earth, the radiation levels were much higher. You know, what we call the terrestrial radiation levels were much higher. So, literally, radiation exposure was not a good thing. And in fact, in the United States, I don't know if you're familiar with how much radiation we get exposed to because of background. You get about 1 millirem per day. So you get about 360 milligram per year just from existing on the Earth. But there are some places in the world, like in Kerala, India. India, for some reason, man, they got like really, really high. What, you know somebody over there? No. Okay, but in Kerala, India, they get over 2,000. They get, yeah, millirem per year. And there's some areas that are higher than that. There's a study online that's kind of interesting about that.
Does it differ in a lot too?
Yes. As you go up in altitude, because the atmosphere protects you and also the magnetic field of the Earth. So, and if you're flying in an airplane, you get an extra 0.5 to 1 millirem per hour that you're in flight.
So before the radiation levels were a lot higher, they're getting lower?
Yeah, remember it's decaying.
Okay, so how does that prove, like, where were you going with the caveman?
Well, there's a thing that, there's a couple of things, okay? First of all, we're going to be looking at where radiation comes from, as far as, you know, how do we contribute additional radiation dose? From what we know, any radiation dose is potentially harmful. So the more radiation you get, the more likely you are to see an effect from it later. Okay? And we're going to kind of compare, there's two types of radiation that we have. One is called background radiation, and that includes cosmic rays. We also have terrestrial radiation. You know, if we looked at the cosmic rays, I don't know if you guys follow the scientific news, but just a few months ago there was a huge solar flare. Okay, The particles that are emitted from the sun like that, or from the stars that actually reach our planet, that's called primary cosmic rays. Now most of those never make it to the Earth. But what happens is that they're traveling at a very high energy, and when they interact with the atmosphere, they actually go through what they call bremsstrahlung. Okay, so bremsstrahlung, remember we have a charged particle and it interacts with other atoms and it changes the kinetic energy into X-rays. Remember that's why you can't have a pure beta emitter in a high atomic number. Okay, so these high energy particles, when they interact with the atoms in the atmosphere, it actually creates like a giant high energy X-ray machine. So when we measure cosmic radiation here on Earth, we're actually measuring secondary cosmic rays. And those are the X-rays and stuff that actually make it through here. Okay? But the big thing for us is what they call, I mean, that's one problem. Okay, I think I've got some numbers here somewhere that I sent to you. Okay, out of that 360 millirem per year, this out of the way here. Just remember where I put it out here. You'd actually be surprised when you look at the breakdown of where this radiation comes from. Actually, I'd be surprised if I could find it. Okay, this is kind of a breakdown. Most of your exposure, now look at that, radon gas. Okay, what do we know about radon gas? Where does it come from?
Ground.
From the ground and from the breakdown of what element? It's from radium. Okay, radium is one of what we call, it's a byproduct of one of the radioactive series. Remember a long time ago, the very first class, we talked about there's 4 radioactive series. And that's actually going to be one of the things we talk about. We have the uranium series, we have the actinium series, we have the thorium series, and we have the neptunium series. Okay, those 4 things produce a majority of radioactive materials. But radon gas is one of the biggies here. So notice out of that 360 millirem that you get exposed to, 55% of it is radon gas. Number 2 cause of lung cancer. Okay, if you inhale radon, remember it's an alpha emitter. Alpha particles by themselves are not bad, but you know if you inhale them or get them in your body, you're in trouble. Okay? Then we have the cosmic rays that we just talked about. So primary and secondary cosmic rays, not very much radiation, only 8%. Other terrestrial radiation, except for the radon gas, 30 millirem. So that's where you're going to get most of your exposure. Some of you may hear a term called radiation hormesis. You ever heard that one before? Yeah. It's a theory that radiation is beneficial, that because of it, it caused mutations, and that's why we're here now. But I don't know. kind of just don't believe in that kind of stuff. I think we're a little bit more complicated than some
So
random.
low doses of ionizing radiation decreases cancer.
Yeah, yeah. I mean, yeah. But anyway, so this is then the internal stuff. Okay, this is a combination of stuff that's produced in the soil, like 40 potassium, carbon 14, and then stuff that's produced by the bombardment of atoms in the atmosphere. So things like, again, carbon 14, tritium. Tritium is hydrogen that's bombarded with neutrons from space. Eventually the stuff settles down into the earth. So we inhale it, we ingest it. The animals eat it, we eat the animals, we eat the plants. So if you were to, take a look at the radiation emitted from your body, you're going to find potassium 40 in there. You're also going to find actually 210 polonium, 210 lead. Those are all in there too. There's nothing you can do about it, so enjoy it. But down here, this is where it starts getting interesting. The man-made stuff. Okay, now this is where like I said, the more radiation you get exposed to, the worse it's going to be for you later on. Unfortunately for us, because we're exposed to low levels of radiation over long periods of time, during our careers, the effects that we're going to see aren't going to show up until later. We kind of found that out with mammography. When I was a student, they used to suggest that as soon as a woman was in puberty, that she should have a mammogram. We didn't realize that the radiation wouldn't penetrate a dense breast, but we tried. We actually found we were causing more cancers than we were detecting, because you expose somebody at the age of 18 or 25, the radiation effects aren't going to show up for 25 or 30 years. So when that person turns 55, they're going to get breast cancer, and we gave it to them. So that's why they do it on older women now, because if you're 40 or 50 years old and the effects aren't going to show up for 30 years, that means that you've already died of something else. You die of heart disease or kidney failure or diabetes, but you're not going to probably die of breast cancer. That's how they figure it, guys. Sorry. Okay, but notice that medical X-rays are the biggest perpetrator of external doses. We're number 2 at 15. Consumer products, if you guys have go through the airport, smoke detectors at home, they typically use americium-241. It's an alpha emitter, and they shoot it at a detector. But if you have smoke particles, it prevents the alpha particles from being detected, and that sets the alarm off. Okay. That's why you never want to open those things up, because there is some radiation source in there. Static eliminators, have you ever seen those? They ionize the air so that you, okay. And then if you have, some watches still have radium dials, the older ones. They actually had some kid back in Kentucky that went around to junk shops and thrift stores and bought up these things, and he actually created a neutron howitzer. He was actually making plutonium in his backyard. Some Boy Scout kid. Yeah, weird. Yeah, he had a radiation detector in his car. Yes. This was a Homeland Security thing when I was back there.
Is that legal?
Oh, no, absolutely not. They had to evacuate a whole... the guy had enough plutonium almost to make a bomb. The way... they tell you how to do it online.
Kids these days.
Yeah. Boy Scout thing. Okay, anyway, then we talked about air travel, and then whenever they change the fuel at nuclear power plants, there's a big thing. I have no idea what the effect of the Japanese, the Fukushima, what's it?
It is Fukushima?
Fukushima, something like that.
Nagasaki and Hiroshima.
Well, but also because of that tsunami, the radiation from that reactor is being detected now in fish here in the United States. So you have to remember that the radioactive stuff that leaks into the soil and plants and everything eventually winds up, going all over the place. So they have stuff that was released into the atmosphere, they have stuff that's released into the water. So maybe that'll keep people from eating dolphins for a while, I guess. But anyway, and then the nuclear bomb testing, besides Hiroshima and Nagasaki and Alamogordo, they used to drop bombs up there in Las Vegas, Nevada. There was a nuclear testing site up there, and they used to explode them above ground. And the fallout from that, I don't know if you remember John Wayne and all of the cowboys. They used to film movies in the area where the fallout from these bombs would drift. Most of these guys died of lung cancer. But of course they all smoked too, so it's hard to say which one killed them. But inhaling radioactive dust, especially from this type of a thing, is not good. Anyway, and the two big ones, I don't have the data from the Japanese tsunami yet. We may have one from San Onofre here pretty soon. San Onofre is in trouble. I don't know if you guys have heard that. We may have to send you guys down there to their Geiger counters. Say, here's a Geiger counter, go on down there. But yeah, this thing here, it says, okay, so 3 Mile Island, that was the very close call for us. People don't realize that most of the East Coast would have been a desert had this thing gone critical. What happens is that when the radiation is ionizing the water, it forms hydrogen gas. And if that explodes, and they lose the containment building, then all this stuff spreads all over the area. And basically, those people that survive, they're going to have to evacuate. But chances are that most of them are going to probably die eventually from the radiation. Chernobyl, on the other hand, notice resulted in 46 megacuries of I-131 being released, 136 megacuries of xenon, 2.3 megacuries of cesium. Cesium's the bad one here. We actually had quite a few of the people that were exposed here at UCLA for bone marrow transplants. One of them was a helicopter pilot that was dropping dirt on top of the fire. He didn't survive though. But, 400 gram. But other people got 20 gram, up to, 200-mile radius of the reactor. So, time to move to Utah, folks. We're going to leave.
That was experimentation too. They were like trying to do experiments, right?
They were playing around with it.
Yeah.
The actual, they were telling everybody that they were experimenting, but one of the sort of undocumented secrets that they have here in the United States was as they were developing the technology for nuclear reactors, they had one built out in the desert, out there in Las Vegas in the testing grounds. And to control a nuclear reaction, you have what they call control rods. If you remember way back when we talked about these graphite control rods that absorb the neutrons and stop the chain reaction. So these guys were apparently playing with it, and that's the only thing that they could figure from. But anyway, the reactor went critical. It exploded. One guy was embedded 3 feet into the containment building, blew right into the concrete. They were so radioactive that they couldn't bury them. They had to dispose of the bodies at the. The head was so radioactive they had to take it off and dispose of it somewhere else. So it was something that, and that's what they think the Russians were doing, after so many drinks of vodka. Say, hey, Igor, how far can you pull it? I hate to say it, but that's probably what happened. Okay. Anyway, why don't you guys take a short 10-minute break, and then we'll get back and talk a little bit about some of the regulatory